Okay, so more application problems here. We're doing number 5. So we got a box. It has a square bottom. Side lengths x and a height h. Okay, so a box with square bottom. The bottom sides are x by x and the height is h. We want to minimize again, so similar to yesterday, minimize the amount of material used, but we want the volume to be 52 cubic centimeters. So we know our volume is 52 cubic centimeters, and we want to minimize the what?
The amount of material used.
So therefore the surface area. Yep, perfect. Both. Minimize the amount of material used, minimize the surface area. Great. Okay, so everyone's clear on what's going on here?
Yes.
Okay. I don't mind drawing just a little bit of a picture here. It's not going to be a great picture. Okay. But we got a box. It has a square bottom. So the bottom is x by x. And the height is h. Right? I like having a visual aid. It usually just helps me to understand. Okay. We want to minimize the surface area. Well, if we want to minimize the surface area, it probably would be helpful for us to write down an equation that represents the surface area of that box, right? Okay?
Yes.
How do you find the surface area of a box?
I don't know. I just wrote 2x squared plus 4x
Right? How many surfaces does a box have?
So,
6, right? Because I'm assuming it has a top to it, okay? So we got the bottom, the top, the left, the right, the front, the back. 6 surfaces, okay? How do you find surface area? Add the areas of all 6 surfaces together. There's really no formula. Find the area of the bottom, add it to the area of the top, add it to the area of the left, add it to the area of the right, add it to the area of the front. I mean, there probably is a formula for it, but I can't memorize a million formulas, but I know how to figure out areas of rectangles, so why don't I just find areas of rectangles and add areas together? That seems simple. I don't have to memorize anything. Okay? So we got the bottom. Let's do the bottom first. What's the area of the bottom? X squared. What's the area of the top?
X squared.
So what's x squared plus x squared?
2x squared.
2x squared. So far, surface area, I got 2x squared. And we've done top and bottom so far, right?
Yes.
Okay. I'll go right side. What's the area of the right side?
H times H.
So xh. How about the area of the front?
XH.
Left side?
XH.
Back side?
XH.
So xh plus xh plus xh plus xh.
4XH.
Great. Good job.
oh,
There's your surface area right there.
oh, okay.
Surface area equals 2x squared plus 4xh.
I thought I
Okay.
got that wrong.
Put me here for me. All right. Now we want to minimize that. So we want to be able to graph that, right? What's our problem? Can we graph it right now? Too many variables. So let's use the other piece of given information, which was our volume. And from that equation, hopefully we could get h by itself and substitute something in for this h, so then our equation is only in terms of x. So help me out. What's that other equation going to look like?
X squared times h equals 52 cubed.
She says x squared h equals 52. Can you explain how you got that? You are right.
Because it's the base times the width, which is x squared, and then times the height, which is 8.
The area of the base, so x squared, times the height would give us the volume, right? The volume of a box can be found by finding the area of the bottom, multiply that by its height, so x times h would give us the volume. So x squared h equals the volume. But what was our volume? 52. So x squared h equals 52. Yes, no, questions, thoughts on that? Okay, what are we going to do?
Divide the x squared.
Because we want to get h by itself. So h equals 52 over x squared. What are we going to do with that?
Plug it in.
Plug it in for the h. So 2x squared plus 4x. And in place of h, I'm going to do 52 over x squared. You could leave it like that. I like simplifying personally, but you could definitely leave it like that if you wanted to graph it now if you're worried you're going to goof up when you're simplifying. 4 times 52 would be, what, 208?
Mm-hmm.
So you get 208
Over x.
over x. So there is my formula for my surface area. What do you do to finish the problem? Graph it and find the minimum. Okay? So we go to our graph. Alright, 2x squared plus what? 208 over x. Before I graph it, I'm going to go to my window. What does x represent again? The length of each side on the bottom of this box, right?
Yeah.
So it's got to be a positive number, and I doubt it's real big, right? Because the volume of the box was only 52, so, I mean, I wouldn't go past 10, because if x was 10, what would the area of the bottom be already? 100, okay? If the volume's only 52, I doubt the area of the bottom is 100. You guys with me on that logic? So I think 0 to 10 is plenty, alright? Now, what does your y value represent? No. Look at your equation. Y is your surface area in this case. Surface area is going to be positive, and probably isn't exactly between 0 and 10, right? I mean, the area of all 6 surfaces probably adds up to be more than 10. So, I mean, I'd go with a fairly large y maximum. Obviously, mine's set on 500 here. You can see that it's going to be okay, but I probably didn't even need to go to 500. I'm guessing 100 was probably plenty. Okay? But, so you want to look at your x. I don't need negative x values. Okay, x value represents the length of one side of the bottom of that box. So 0 to 10 is probably a perfect window range to be looking at. Y represents surface area. I definitely am not going to have a negative surface area, so I can put my y minimum at 0, and then you make your y max whatever number you'd like to make it. Okay? So then you take a peek at the graph. There it is. We're finding the minimum. So we go to second, trace. We're finding the minimum. That's number 3. We want to make sure we're somewhere left of where that minimum occurs. And we got to get somewhere right of where that minimum occurs. I got 3.73 and 83.6.
Yeah.
Okay? So 3.73, that's our x value, so that represents the dimensions of the bottom. So the bottom of this box would be 3.73 by 3.73. The 83.6 represents our what? Surface area. Okay? So our surface area is 83.6, are we in, yep, centimeters squared. And my dimensions of the box would be, what was it again? 3.73 by 3.73 by, I still need what dimension? The height. If I know that x is 3.73, I would substitute it in right here. 52 divided by that 3.73 number squared will give you your height. A little bit of help from anybody that's done that for me already.
7, oh, I took it times it,
I thought like 3.73, but I feel like that's not right.
That's what I got on the side.
Okay, maybe it is.
That's what I got, 3.73.
Yeah. Actually, yes, it would be in this case. So there are your dimensions of the box, 3.73 by 3.73 by 3.73, happens to be a cube. And then this is the surface area of that box, and that would be the minimum surface area. Okay, so that was number 5 on your worksheet. Okay, that we just did together. Okay, what questions do you have on that? Yes?
So like, would the minimum surface area of a rectangular prism always just be a cube?
As long as they don't put any requirements on the different sides of the box, then yes. If they tell you that we need the height to be twice the length or something like that, then obviously, no, it won't be. But if they don't really give you any requirements like that, if they just say create a rectangular prism with a maximum volume, or excuse me, create a rectangular prism with a set volume and use the minimum amount of materials, it will always be a cube. Okay? All right? Okay, any others? Anything from the textbook that you looked at that was tough?
Do you want to do number 4 from the worksheet?
So,
Just,
Graphing.
I don't know, just a
so
random
that's a
thought.
different one.
We don't have to, I'm just throwing problems out there.
Yeah, we kind of talked about 4 yesterday. It should be, all you're going to do is graph it, and there's really no work. And what are you going to look for on the graph?
Max?
Can you refresh on how we find the time?
Okay. So this is my y value, this is my t value. The graph's going to look something like this. Right? It's an upside down parabola. It says, find the time it takes to reach the maximum height. So if you locate this coordinate right here, that'll give you an x value and a y value right there. The x value of that coordinate is how much time it took to reach that height. So if this is, 3, 62, that means it took 3 seconds to reach a height of 62 feet. So when it says, find the time it takes to reach the max height, your answer would be 3 seconds. Find the maximum height, the answer would be 62 feet. And then the time it takes for it to hit the ground, you just come over here and search for that 0 right there. And whatever x value that is, that will tell you how much time it took for that object to hit the ground.
Got it.
So, you guys are able to identify maximums on a graph and find zeros on a graphing calculator?
Mine doesn't find the maximum.
How do you get those top points then?
I don't.
You have to use a different calculator, what you end up doing, or like on that last problem that we just did where we found the minimum.
It doesn't find the exact numbers.
She had similar ones. It was like 4,
It was 4 and like 2.8 or something.
Yeah,
yeah, 83.
we gotta figure out how to do that on yours, or you're gonna have to use a different calculator. Have you tried Googling how do you find maximums and minimums on your calculator? That's what I would do if I were you. I can try and help walk you through it, or again, just grab a different calculator. Okay? Alright, anything else? Any other problems you've seen that you want to go through? Since I'm not seeing too many books open, I guess we haven't looked too closely at the book ones, so I'll stop for right now. You guys work for the remainder.